The ocean surface looks calm from a distance, a thin, blue plain broken only by light wind and occasional ripples. But at this boundary, where air becomes water, life follows different rules. Just beneath the surface, a small shape drifts upside down, its blue front to the light, its limbs trailing into the depths. It does not swim, it cannot flee. The wind decides its path, and the currents decide its fate. For most animals, this would be a death sentence, but this one feeds on danger itself. It hunts floating siphonophores, jellyfish-like animals, armed with venom powerful enough to kill fish and seriously injure humans. This is the blue sea dragon, a predator not by strength or speed, but by surrendering to the whims of the ocean, and by using the weapons of its prey in its own defense. If you'd like to learn more, check out the document in the description with research papers and image credits. It may come as a surprise that the blue sea dragon is not, in fact, a dragon. And technically, it isn't blue either, although it certainly looks that way. We'll return to the question of coloration later. For now, what are blue sea dragons? They are nudibranchs, soft-bodied marine gastropods, often loosely referred to as sea slugs, though that term isn't a formal evolutionary group, as it is commonly used for several different unrelated groups of marine invertebrates. Like all gastropods, their distant ancestors carried a protective shell. But over time, nudibranchs lost that shell entirely, trading physical armor for a very different set of defenses. Without a shell, most nudibranchs rely on chemistry instead. Many feed on toxic or chemically defended prey, sequestering those compounds in their own tissues. Bright colors often serve as a warning, advertising that they are unpleasant or dangerous to eat. For the vast majority of nudibranchs, this life unfolds on the sea floor. They crawl slowly across reefs and rocky substrates, feed on sponges, bryozoans, and cnidarians, their bodies shaped by a world of solid surfaces and shelter. The blue sea dragon belongs to this group, but it has abandoned this familiar world entirely. Nudibranchs are often grouped into two broad forms. Dorades tend to have flattened bodies, with feathery external gills arranged toward the rear. Aolids, by contrast, carry rows of finger-like projections, called serrata, running along their backs. In aolid nudibranchs, those serrata are not just decorative. They increase surface area for gas exchange, but more importantly, they are extensions of the digestive system. Branches of the digestive gland run into each serous, carrying nutrients, and in some species, something far more dangerous. To understand what that something is, we need to briefly step sideways to a very different group of animals, the cnidarians. Cnidarians, the group that includes jellyfish, sea anemones, and corals, are defined by a single, highly effective weapon. Their tissues are armed with stinging cells called nematocysts, microscopic capsules that fire harpoon-like threads, injecting venom on contact. These stings are powerful enough to deter or kill many small animals, which is why most predators avoid cnidarians entirely. Aolid nudibranchs are a rare exception. Instead of triggering these stings, they can ingest cnidarians without discharging the nematocysts, allowing the cells to pass intact through the gut. Those stolen stinging cells are then transported into the serrata, where they are concentrated and stored, ready to be used in the nudibranch's own defense. The blue sea dragon is one of these aolids, but unlike most of its relatives, it does not crawl across the reefs in search of cnidarians. It drifts at the ocean's surface, feeding almost exclusively on floating siphonophores, and it has built its lifestyle entirely around that dangerous diet. This radical way of life is only possible because of a long evolutionary experiment. Blue sea dragons are the culmination of a lineage that traded armor for chemistry and structure for mobility. The loss of the shell in nudibranchs was not a single evolutionary gamble, but the opening of a new pathway. Freed from the constraints of carrying heavy armor, these animals diversified into a wide range of forms, colors, and diets, often specializing on prey that few others could exploit. Chemical defenses, camouflage, and warning coloration replaced physical protection, allowing nudibranchs to occupy ecological niches closed to more heavily armored gastropods. The blue sea dragon represents one of the most extreme outcomes of this trajectory. Rather than refining life on the sea floor, it abandoned it entirely, pushing the nudibranch body plan into a habitat defined not by structure, but by motion. In doing so, it demonstrates how evolution does not simply optimize organisms for strength or efficiency, but for persistence, shaping even fragile, drifting animals into specialists capable of surviving at the very edges of what life can tolerate. To survive this lifestyle, the blue sea dragon had to solve two problems at once: how to stay afloat in a world without shelter, and how to feed on prey that most animals cannot touch. The blue sea dragon lives in a habitat most marine animals never occupy for long, the neustonic layer. This is the thin boundary at the ocean's surface, where water meets air and where life is shaped as much by wind as by waves. Unlike most nudibranchs, the blue sea dragon does not swim or crawl. Instead, it remains buoyant by swallowing air and storing it within its stomach, allowing it to float just beneath the surface of the water. In this position, the animal lives upside down, its underside turned toward the sky, suspended at the surface by a delicate balance of buoyancy and tension. This way of life comes with severe constraints. There is no shelter, no substrate to cling to, and little control over direction. The wind determines where the animal drifts, and storms can carry entire populations ashore in a matter of hours. But the surface also creates opportunity. Floating prey accumulates here, drawn together by currents and convergence zones. For an animal adapted to tolerate venom, the neustonic layer offers access to food sources that few others exploit. The blue sea dragon is not fast nor strong, nor particularly well protected by size. Its survival depends entirely on this narrow strip of ocean, and on what it finds drifting there. Among the drifting life of the neustonic layer are some of the ocean's most effective predators. These are the siphonophores, colonial cnidarians made up of many specialized individuals or zooids, working together as a single individual. The most familiar example is the Portuguese man-o'-war, Phasalia phasalis. Though often mistaken for a jellyfish, the man-o'-war is a floating colony, armed with long tentacles, loaded with some of the most potent nematocysts found in the ocean. These stings are capable of killing fish and can cause severe injury to humans. For most animals, this makes siphonophores untouchable. For the blue sea dragon, they are the primary food source. Blue sea dragons feed by biting off sections of tentacle and tissue, ingesting them without triggering the mass discharge of stinging cells. Remarkably, this process depends on precise biological control. Inside most animals, contact with digestive enzymes or changes in chemical conditions would cause nematocysts to discharge prematurely or break down entirely. Aeolid nudibranchs, including the blue sea dragon, appear able to prevent this by controlling the environment within their gut, allowing intact stinging cells to pass through without firing. Once transported into the serrata, those nematocysts are not simply stored at random. They are concentrated into specialized structures called cnidosacs, where they remain connected to the animal's nervous system. When a predator makes contact, muscular contractions trigger the discharge of the stolen stings, effectively turning the serrata into a living weapon. This process is known as kleptonidae, klepto meaning to steal, and nidae referring to the stinging cells of jellyfish and siphonophores. This strategy is not without risk. Mishandling venomous prey or failing to properly isolate the nematocysts can be fatal. For species able to manage it, however, kleptonidae offers a powerful advantage, a defense system that does not need to be evolved from scratch, but can be assembled piece by piece from the bodies of other animals. In the blue sea dragon, this borrowed arsenal reaches an extreme, built entirely from the drifting predators it consumes. Life at the ocean's surface presents not only challenges for feeding, but also for reproduction. Blue sea dragons are hermaphrodites, possessing both male and female reproductive organs, which allows any two individuals to meet and mate. But they cannot fertilize themselves, and encounters are rare in the vast neustonic layer, so timing and change play a critical role. Mating occurs at the surface, with pairs often aligning upside down as they exchange sperm. Afterwards, both individuals can produce long ribbons of eggs that float near the surface, tethered only by the delicate architecture of their gelatinous threads. These ribbons then drift with the currents, sometimes attached to floating debris. This spreads the offspring over potentially hundreds of kilometers, increasing the likelihood that some will survive in such a dispersed and unpredictable habitat. The challenges do not end there. Being entirely at the mercy of the wind and waves, the blue sea dragon must remain precisely positioned at the ocean's surface, the narrow neustonic layer where buoyancy, feeding, and survival all intersect. Too much turbulence can force it below the surface, cutting it off from floating prey, while onshore winds and breaking waves can carry it irreversibly onto land. Small adjustments in body posture, the curling of the tail, and subtle movements of the serrata influence how the animal rides surface tension, helping it remain suspended in this thin, unstable boundary. Even upside down, this delicate balancing act is essential. A difference of only a few centimeters can mean the difference between feeding, drifting, or dying. In this way, reproduction, buoyancy, and surface behavior are intertwined. Every action is governed by the physics of the interface between air and water, and every success, from finding a mate to laying eggs, depends on mastering life at the margins of the ocean. Earlier, we mentioned that the blue sea dragon is not technically blue. This is because the color is not caused by pigmentation. Instead, much of the coloration comes from structural effects, microscopic features in the animal's tissues that scatter light, reflecting blue wavelengths rather than absorbing them. It's a similar physical principle to what produces iridescent colors in many birds and butterflies. But the placement of that color matters as much as its origin. The blue sea dragon floats upside down at the ocean's surface. Its ventral side, facing the air and sunlight, is deep blue, blending with the color of the open ocean when seen from above. Its dorsal side, facing downward into the water, is silvery grey, reflecting light and helping it blend into the bright surface when viewed from below. This inverted color pattern provides effective countershading for a life spent drifting at the surface. Countershading is a common defensive strategy in aquatic animals. Penguins, sharks, and many others use a similar approach. A darker surface reduces visibility from above, while a lighter underside blends into the light at the surface when seen from below. At the same time, the blue is vivid, high contrast, and often strikingly visible when the animal is washed ashore. Combined with its stolen stinging cells, this may also function as a warning signal, advertising that, despite its delicate appearance, the blue sea dragon is not safe to touch. Exactly how much of this coloration functions as camouflage and how much as warning remains an open question. But in a habitat with nowhere to hide, being both hard to see and dangerous when noticed may be the only workable strategy. For most of their lives, blue sea dragons remain out of sight, drifting far offshore. But because they are entirely at the mercy of wind and currents, they can sometimes appear suddenly and in large numbers along coastlines, transforming an otherwise empty beach into a scattering of vivid blue shapes. These events are not random. Strong onshore winds, seasonal weather patterns, or shifts in surface currents can push entire neustonic communities toward land. When that happens, blue sea dragons may wash up alongside other organisms that share their drifting world. Siphonophores, like the Portuguese man of war, floating snails, and fragments of pelagic life rarely seen by people. Such strandings can create the impression that blue sea dragons are rare, newly arrived, or even invasive. In reality, they are usually present just beyond the horizon, living unseen until conditions deliver them to shore. What appears to be an animal is often simply a moment of visibility, a brief intersection between a pelagic life and a terrestrial observer. For the animals themselves, stranding is almost always fatal. Unable to return to the water, they quickly succumb to dehydration, exposure, or physical damage from waves and sand. Their presence on beaches is not part of their life cycle, but the inevitable consequence of living at the surface in a world shaped by wind. Despite their delicate appearance, washed-up blue sea dragons should never be handled. The nematocysts stored in their serrata remain active even after the animal is dead. and contact can result in a painful sting, sometimes more intense than that of the siphonophores they feed on. For beachgoers, the safest response is simple: admire them from a distance and leave them where they are. They are not aggressive, not fast, and not seeking human contact, but they are exceptionally well defended. From coral reefs and rocky seabeds to the drifting world of the ocean's surface, nudibranchs show how far a single body plan can be pushed. In the blue sea dragon, that plan has been taken to an extreme. Stripped of its shell, untethered from the seafloor, and shaped entirely by wind, light, and venom. Survival here does not come from speed or strength, but from surrendering to the currents, and from turning the most dangerous prey in the ocean into protection. Yet, this specialization comes with limits. Life at the surface offers opportunity, but no margin for error. Storms, shifting winds, and changing currents can transform an invisible offshore existence into a fatal encounter with land. The blue sea dragon thrives not because its world is stable, but because it is exquisitely tuned to instability, a reminder that some forms of life persist only by occupying the narrowest of ecological boundaries. I hope you enjoyed this journey into the blue sea dragons. If this video sparked your curiosity, don't let it stop here. Share it, talk about it, and keep learning. There's still so much to discover about the world's rare and remarkable species. And the more we understand, the better our chances of protecting them. Thanks for watching.